So for today we are going to talk about polygons, and with these polygons we're going to be talking about their internal angles versus their external angles. Or their exterior versus their interior. So first thing I want to double check is that you know what a polygon is. If you remember, a polygon is a closed figure with straight sides. So just so you know, this shape, which you guys know is a circle, is not a polygon. But if I have two sides, that's not a polygon either. I'd have to close this shape. So here is a polygon. I can move that over in the examples. Okay, it doesn't necessarily have to be a shape that you recognize. If I do straight lines, so if I do something like this, this is also a polygon because it consists of straight lines and it's a closed figure. And if you count, it's a 1, 2, 3, 4, 5-sided shape. So we'll talk about what 5-sided shapes look, what the name of them are. So I just wanted to let you know that that's what a polygon is. Poly means many and gon means size. Okay? So, you can write down, a closed figure with 3 or more straight sides. I mean, that's basically our explanation. It's not a formal definition. And then a regular polygon. Whenever you see this word regular, it is very important that you understand that all sides and angles are congruent. It doesn't mean that it's just normal. It means something special. It means that all the sides and angles are congruent. Now that's very important because sometimes they'll slip that word in on a word problem and you won't see it, and then you will miss potentially important information that could help you solve the problem. So examples of regular polygons would be something such as a 4-sided shape with 4 equal sides and 4 equal angles, which you guys could recognize what this shape is right here. This is a square. Okay? Keep in mind, this is not an example. A rectangle does not have 4 equal sides, so that's not an example. If I have 3 sides and 3 angles that are equal, you guys know this as equilateral. And there are other ones we'll discuss. You'll see the pictures below. So that's important that you know these words. So let's see if you can name these. Pause the video. See if you can name all 7 of these types of polygons. Now keep in mind, I may have drawn them to be regular, but not necessarily am I telling you they are. So everything that has 3 sides is called a blank. Everything that has 4 sides is called a blank. See if you can find out. So let's see if you know what each one is called. Number 1, everything with 3 sides is called a triangle. Everything with 4 sides is called a, some of you said square, but remember, 4 sides is a quadrilateral. So that includes even a rectangle is a quadrilateral. 5 sides is called a pentagon because it looks like a penthouse. Here's my little penthouse. Okay, my penthouse is right at the top. 6 sides is a hexagon because of the number 6 and hex. They both have the letter X in it. Then for number 5, if I have a, what is this? 1, 2, 3, 4, 5, 6, 7, 8 sides. An 8-sided shape is called an octagon. I know I skipped 7, but that's because that name is not used often. 7 is septagon, or some people say heptagon. It goes by 2 names, but it's not usually used, so that's why I skipped it. Number 6 looks like I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So I know I skipped 9 sides, which 9 sides is a nonagon. But 10 sides, like 10 years, is a decagon. And number 7 has 12 sides. Now a 12-sided shape is similar to decagon, where it's the 10, and then you need 2 more, so dodecagon. Whoops. A dodecagon is a 12-sided shape. So now the reason why I went over these is so that you can discuss how many sides and angles they have. And then talk about their interior angles, which are the ones on the inside, and their exterior angles. So let's talk about what an exterior angle of a polygon looks like. If I have a triangle, an exterior angle would be as if I extended one of these sides. There is my exterior angle. Even if I have a pentagon, if I extended one of these angles, here's my exterior angle. So make sure you're not doing something like this where you're just, poking out randomly and saying, hey, that's my exterior angle, because it's not. If you notice, it's not an extension of one of the sides. It bends here, so that's the problem. If I want it to extend to be an exterior angle, it has to be straight along that line. So now, I could do a quick activity, but I just wanted to let you know that the exterior angles of any polygon is always the same. So if I extended these angles, these three angles, so if I have a three-sided shape, the three exterior angles should add up to 360. So same thing here. If I just extended 1, 2, 3, these three angles should add up to 360. 1, 2, so this angle, 3, 4. Notice I'm always going between the extension and the other side of the shape. They should always add up to 360. So no matter what, in any polygon, the exterior angles will always add up to 360. So here are a few practice problems that I already did the answers to. They're in the attached document. So for a pentagon, I need 5 exterior angles. So 1, 2, 3, 4, and then this fifth one, which they did not give me. They gave me the interior angle. But I know that these two form a straight line, so they're 180 degrees. So I subtract it, and I get 40. And then the math for the remaining problems is there as well. So exterior angles add up to 360. That's one thing I want you to know from this lesson. And then the second thing is talking about the interior angles. Now the interior angles can get a little tricky. It's not the same for every polygon, but there's a trick that you can do for every polygon to figure it out. Now with a triangle, you know the sum of the interior angles here is 180 degrees. Now if you look at a square, I can't just, or a quadrilateral, I can just add them up because we know how quadrilaterals work, but it doesn't work for all of these shapes, because now I want to talk about, what about these angles? What's the sum of them? Or these angles, what's the sum of them? So what I'm going to do is I'm going to teach you a trick. If you can cut a shape from vertex to vertex where you get triangles, look how many 180s I have here. I have 2 triangles. So 2 triangles means I have 2 180s. Then looking at the next picture, watch this. So I'm going to make as many triangles as I can. From vertex to vertex. Look at that. I made 3 triangles, so I have 3 180s. Now I'm going to do it with this next one. So notice I'm starting from the same corner, and I'm just trying to make triangles everywhere I can. Look at this. I have 4 180s. So the trick is that you can turn every every polygon into a bunch of triangles. And that's how many 180s you would have. So notice how you only had 1 180 when you have a 3-sided shape. You have 2 180s when you have a 4-sided shape. 3 180s when you have a 5-sided shape. And 4 180s when you have a 6-sided shape. So notice the relationship here. You will always have 2 less triangles than the number of sides that you have. So notice -2, -2, -2, -2. So there is a formula that a lot of people like to use. They say, okay, n is my number of sides. If I subtract 2 from it and multiply it by 180, that's the sum of the interior. Oops. So you might see that formula, but I kind of gave you the shortcut method into which how you can figure it out. So I have a few practice problems here in which I've already completed. So notice what I do here. If I have an 8-sided shape, I'm going to have 6 triangles, so 6 180s. That means the sum of the interior angles here is 1,080 degrees. But it says what is each interior angle. So if the sum of them is 1,080 degrees and I have 8 sides, when I divide it by 8, that's each individual angle. So that's really how you have to do the math here. If you have any questions, you could definitely reach out to me. I've already really explained the difference between the sum of interior and exterior, although I understand sometimes it's a little challenging. So you might want to try the practice problems before you look at my answer key. I hope you guys have a great day. Bye.